All right, so 2.3, calling methods without parameters. And it first starts off talking about methods, something we talked about the past 2 lessons. And it said methods are a set of instructions that define behaviors for all objects of a class. Okay. For example, in the turtle class, when we used forward or turn right, pen up, pen down, okay, those give turtle objects the ability to move forward and to make different movements. Okay. To use an object's method, and I guess first I'll say this, in this project, we're going to be using our turtle to draw different things, and it's going to ask us to draw numbers and shapes, and we just have to use the methods that's given us in order to do that. Okay. To use an object's method, you must use the object name and the dot separator. We've already talked about this. So the dot operator followed by the method name. For example, when we use Yertle.forward or Myrtle.forward or Steve.forward, whatever the turtle's name is, and the dot separator, and then the method name, and then ending with a semicolon, okay, that creates a call to the object's method, okay? And the standard, the default, if you just add forward without any argument in there, okay, that's okay. It will accept that and it will automatically default to 100 pixels. Okay. These are called object methods or non-static methods. We'll talk more about static and void and public and private. Talk about that later. An object method must be called on an object of the class that the method is defined in. Okay, object methods work with the attributes of the object, setting the direction of the turtle or the color, and are able to update its attributes as well as its position. Every method call is followed by parentheses. Okay, we have those parentheses there, open and close parentheses. If you forget one of the to close your parentheses, it's not going to work. Okay, the parentheses after the method name are there in case you need to give the method parameters. If you need to give the method an argument to do its job, which we will see in the next lesson. You must always include parentheses after the method name. And it shows you like the object name, whatever the object is, whatever that instance is, the dot separator, and then the method name. Make sure to add the semicolon afterwards. Okay, the following code uses a turtle to draw the digital number 7, but the lines are mixed up. Drag the code blocks to the right and put them in the correct order. To first draw the line going up towards the top of the page, and then turn, I'm guessing, to the left and draw a line to the left to make a 7. Remember, the turtle is facing the top of the page when it's first created. The default for the turtle is create that turtle and it's going up. All right. So our public class called DrawL. I'm going to open that and I'm going to close it. Okay. I'm going to create my main method here, put it in there. And I'm also going to end my main method. Just getting in the habit of doing that ahead of time. So that way we're not trying to close everything at the end and trying to line up our curly braces. Okay. So it gives us a few options. First, what we want to do is we want to create our world. It says world habitat is assigned a new world. It's going to be a 300 by 300 world. That's where the turtle is going to be located. Then I'm going to create my turtle object and I'm going to name it Yertle. And we're going to place the turtle inside of the habitat. Okay. Remember, it says we want to start at the bottom and move up, and it's already facing up. So I'm just going to say Yertle.forward. That will draw my turtle going upwards 100 pixels. And then we want it to turn left and move forward 100 pixels. It's not a very nice looking 7, right? It's more of like half a square, right? We're halfway done our square, but they're calling that a 7. At the end, I want to show my habitat. All right, so 4, 2, 7, 5, 9, 6, 3, 8, 1. And then I'm going to run my code. It says perfect. Only took you 1 try to solve this. Great job. All right. It says after you put the mixed up code in the order above, type the same code below to make the turtle draw a 7. If the code does not work for you, you can also use the turtle, okay, at replit. So we are making our turtle, our Yertle, the turtle, draw a 7. So I'm just going to say Yertle dot forward, and then say Yertle dot turn left, and then Yertle dot forward. I believe that's the same as what we just typed, what we looked at above. That is. All right, our habitat in the end show true. You can add as many, like as much space in between this as you want. Typically, it's not like nice to just leave huge blanks there. So I'm gonna go ahead. Just clean that up a little bit. All right. And I'm gonna run it. There you go. It's an ugly looking 7, right? I guess if you wanted it more like a 7 without diagonal lines, you would go up 100 and turn left and maybe go like 50, right? That'd probably be a nicer looking 7. I wouldn't see that and think, oh, that's a 7. But it works. Can you make Yertle draw the digital number 8 as 2 squares on top of each other? Interesting. Okay. So let's think about this. And it doesn't want us to use loops yet, so we're not going to use loops. We're just going to write this out. I'm gonna make it move forward 50. That'll make it move up 50. And then we're going to turn left. And I'm going to copy that because I'm being lazy or efficient. I should probably spell Yertle right. All right. And then I'm going to make him move to the left. And then again, and again. Now, at the very end, instead of making him turn left, I'm going to have him turn to the right. Because if you think about it, I have my guy starts off here. He goes up 50, 50, 50, 50. If I have him turn left, he's going to follow that same path. So I'm going to have him turn right. And then I'm going to have him, let's say, we'll make him move forward 50. That'll make him move down. And then the bottom of the square. And then the left side of the square. And the square is already finished there. It should be already finished, but I think it wants me to return to my starting position. Okay. So let me just explain what I did. Let's run it first, then I'll explain it. All right. See, I could have stopped right there, but I wanted to go to the starting position, and I didn't have him turn or anything. Okay. I think that works. Yeah. The requirements asked me 2 squares on top of each other. So I made 2 squares. So what I do, I had to move forward, turn left, turn left, turn left, forward, finally completed my first square. Then I had to turn right to go the other way and went all the way through. And at the end, just didn't have it turn any direction. Okay. So that's what my code looks like. What's up? Could be a variety of reasons. It could be the server. It could be the internet access. It's probably because, I mean, they straight up tell you right here. It says, if the code below does not work for you, AKA if it's running way too slow and it's frustrating, you can use this. So they created their own IDE here for you online for you to type your code into. But normally it doesn't take that long to run. If you are using Replit or you're using, I really enjoy Eclipse for Java. You can download Eclipse on your computer. That's a good IDE. All right, 2.3.1 procedural abstraction. Now, we're going to introduce the concept of abstraction. And in AP Computer Science Principles, it's like the biggest thing we talk about. Okay, simply put, abstraction is the removal of details. Okay, you're taking away details so someone can learn something. Okay, the best way I can put abstraction, okay, this is one of the best examples I can give. If I flip my light switch on, do I need to know how electricity works in order to flip that switch on? No, I don't. Can I learn how electricity works? And that maybe help me troubleshoot problems with my electricity? Yeah, I could. But all you need to know is that every time you flip that switch, my light turns on. Every time I flip the switch down, the light goes off. My 1-year-old son knows that. Okay, my 1-year-old who can't even speak yet. Every morning he wakes up and we'll take him over and he wants to flip the switch to turn the light on. Right? He knows what it does. He does not need to know how electricity works. Okay? He doesn't need to know how our own electricity works in our house. All he needs to know is what it does and when to use it. He does not need to know all the time the ins and outs of the why or how. Okay? How to use it is great. How it works is entirely different. So the concept of abstraction is important in computer science because we want to make building apps or writing programs or writing software. We want to make it as easy as possible for developers, but at the same time, give them the power to do what they need to. So even the Java programming language is an abstraction from the actual ones and zeros that the computer reads, right? In order to drive a car, right, you don't need to know how your engine works. You don't need to know that how when I push that button to start my car, right? When I push that button, I don't need to know how behind the scenes everything functions for my car to start. I can learn if I really want to, but you don't need to. So that's one thing that sometimes we get caught up in. We get so focused on what happens behind the scenes, and we are very inquisitive and want to know, but we get so caught up in this little concept that we might end up getting really confused and frustrated, which is totally me, 110%. I always want to know the why and the how it works. But I always don't need to know right away. I can always go back and learn it. So this says, so the concept's name is abstraction. Abstraction is the removal of detail. All right. So when it says procedural abstraction allows a programmer to use a method and not worry about the details of how it exactly works. We've been using the forward method from the Turtle class, but you don't need to necessarily know right now how that works. You can learn if you really want to, but as a beginner, you don't necessarily need to know. Okay, for example, we know that if we hit the brakes, the car will stop, and we can still use the brakes even if we don't really know how they work. Okay. And that's important because some of these concepts early on, I'm going to teach you what it does, but I'm not always going to teach you the why and the how right away. We will eventually dive deeper into it. The same way we learned what the main method does, it's where the program starts. We're not going to dive in why we're typing these exact keywords. Okay. You'll learn how to write your own methods in Unit 5. In this unit, you should be able to use the methods already written for you. Okay, so someone wrote these methods for you. Let's use them. And we're going to figure out what they do. When we use methods for a class in a library, we look up the method signature. Okay, what the method does, which is the method name followed by the parameter list and its documentation. It says, for example, here is a student class with a method signature public void print. Okay, which has an empty parameter list with no parameters. Methods are defined after the instance variables or the attributes and constructors in a class. All right, so let's take a look at this. We'll break this down. So we have a public class called student. These are some instance variables, basically just defining the attributes, right? The default, defining that we have a string called name and we have a variable string called email. Doesn't assign it any value. These are just attributes of the student. Okay, then we're creating a constructor to initialize the attributes. This is just creating the attributes. Now we're going to initialize them. Okay, it says the implementation is not shown. A constructor to initialize the attributes. For a student object with the given parameters, public student string, initialize the name, string, initialize email. Okay, so we're collecting that. I don't like how they just like plopped all this on top of each other here, because this right here, that's one, and then down here, that's another. Okay, so that receives right there. That is, as you would say, at the very top, how we mentioned calling a method without parameters. Okay, this doesn't expect any parameters. Okay, this has 2 parameters that it tells you they're going to be strings. So if you try passing an int or a double or a Boolean value in there, it's not going to like it. You get an error. Okay, then it says public void print. Okay, and it says method to print student attributes. So you would say like student dot print in order to do that. A student class showing instance variables, constructors, and methods. That's what it says. We have our attributes, we have our constructors, and we have our method. Okay. All right, let's take a look at this. It says click on the method headers signatures in the following class. All right, so this is where we're declaring our instance variables. This is our class, opening our class, instance variables, and this right here defines our method. Okay. All right, sorry, this is our constructor. Okay, this is our other, this right here is a string. So this is going to be a method that's being used. And this is our method that's being used. This is our constructor. Go ahead and take a look. You're correct. Okay, so I had originally clicked on this. I was thinking about the constructor and the method that would be inside of it, but there is no method inside of it. Our constructor, our instance variables, our 2 methods. Okay, it says the Java visualization, and then there's like a link. All right, it says the Java visualization below shows how a song can be divided up into methods. Click on the click on the next button below the code to step through the code. Execution in Java always begins with the main method. Then the flow of control skips from method to method as they're called. Flow control is important when we start talking about conditional statements later on. The song's print method calls the chorus and animal methods to help it print out the whole song. When you call the chorus method, it skips to the chorus code, executes and prints out the chorus, and then returns back to the method it called. Okay. Methods inside the same class can call each other using the method name that's being called. But to call non-static methods in another class or from a main method, you must first create an object. All right, so we're asking what the following code prints out. Let's just take a look at it. Here's our class. Okay, we have this method here. And whenever we call song.print, it will say, I like to. And then whenever we write the eat method, it calls eat. It's down here. So it just prints out eat. Then it calls eat again. And it says eat. And then it calls eat again. And it says eat. And then it calls fruit, which right here says apples and bananas. Okay. There's also your main method at the very end right here. Check this out. Our main method initializes this object from the song class, and it says S. It then calls print from the S class or the student class. I'm sorry, the song class. And so right here, this is where the code actually, remember the main method's where it starts. So it finds the main method. This is what your computer is going to do. Your computer is going to find the main method. It's going to realize you're about to call something from the song class and looks for print. It finds the class called song. It finds print. It does what it wants you to do. It uses system.out.print, and then moves on and completes it. It finds eat again, it finds eat again, and then it finds fruit. So this should say, I like to eat apples and bananas with an exclamation mark. D. Let's check it. That's right. So we're starting to realize, obviously loops can loop through things and make them easier. But by writing classes also can allow us to write less code. In this case, we really didn't write too much. We created a eat just to actually print eat, which is a bit ridiculous. But if we're writing really long programs and we're reusing the same thing over and over and over again, it is important to create these methods and to create these classes. All right. So I like to eat apples and bananas. It says try this visualization to see the code in action. I'm just not going to do that. All right. Let's keep moving through this. Before you call a method from main or from outside the current class, you must make sure that you've created and initialized an object. For example, if I wouldn't have created this S object from the song class, I couldn't actually have used this print, right? I couldn't have done that. Remember that if you declare an object reference without setting it to refer to a new object, it will end up being a null. And you might get this exception, which is an error. Whenever you see exception, eventually we'll talk about exception handling, talking about how to handle errors. But a null pointer error, okay, is when you end up getting null. Nothing's actually there. It says a pointer is another name for a reference. It points at it and says, hey, look, there's a problem. Okay, 2.3.2 programming challenge. Let's draw a letter. Okay, we're winding down here. This is the last thing before we go through the summary. It says working in pairs. You don't need to work in pairs. Use a turtle to draw a simple block style letter or number that uses just straight lines, no curves or diagonals. It could be one of your initials or a number. All right. It may help to act out the coding, pretending you are the turtle. Remember that which way you turn depends. I usually like writing things on a notepad. I'm a very visual person. Doing like math in my head, even is difficult. I like seeing things. Okay, so here are some simple turtle methods. We already know them. All right, let's do it. So we have to first create our turtle. Okay, and if you look back up here, when we were creating our turtle in the past, just as a reference, I'll copy what we had. Maybe we won't name him Yertle. We'll say all right, we're going to create a turtle, and we had used the name Steve before. So I'll say Steve is a new turtle, and we're going to place him in the habitat. Okay. Now that I have the turtle, it's going to start him right in the center. He's automatically default facing forward or facing up. What letter do we want to draw? What about an M? Okay, what if we draw an M? So go up. We'll have him go up. Steve dot forward, and we'll make him move forward 50. And then we want Steve to turn right. Yep. Boom, turn right. Then he's going to move forward 50. So he moves up, turns right, moves forward 50, turns right. Then I'm going to have him move forward 50 again. And instead of turning right, okay, now he's facing down. I want him to face left. So I'll say turn left. After he turns left, I'll have him maybe say Steve dot forward 10. Okay, just to draw the bottom side of it. So I guess if I'm actually going through and drawing this, right, I'm starting here, he's moving up. Okay. If I'm doing that, then maybe I'll change this to like 30. Okay, so he goes up 50, he'll go around 30, he'll go down 50, he'll go to the right about 10. Then we need him to, after he's gone forward, we need him to turn left. Let's see. Yeah, turn left. Steve dot turn left. And after he turns left, we want him to move forward again. We want him to move forward 50. I'm just thinking about what the shape would look like. Now we're at the top of it again. So we want him to turn right. Okay, so once he turns right, I'm going to have him move forward 30. And then turn right again. And then move forward 50. So this is what I got. This is just my M, and the shape that it should look like I said, it'll go up, it'll go over a little bit, it'll go down, it'll go over a little bit, it'll go up, go over a little bit, and down. It's not going to look pretty, but There you go. That's the shape I was thinking of, right? It's not the nicest thing in the world. If I wanted to have it not go down as far, I could, or I could have it go right back up instead of even moving over this way at all. I could have had it go up, over, down, and then back up, and then over, down. That's an ugly M, but I don't think our 7 was much better. Yes. Yeah. And you can do whatever you want. And I encourage you guys to play around. You don't have to draw exactly what I draw. If I wanted to then say like pen up, I think that was the command, right? Pen up. Yeah. Okay. And then maybe I'll say turn left, Steve dot turn up, turn right. I'm just going to move him around a little bit. And after he's turned to his right, he has moved, let's see, that was 30, that was 10, that was 30. So I'll have him go Steve dot forward 70. And that should take him back to his starting position, right? So if I'm looking at this right here, like I said, not a beautiful M. Pen up, turns, and goes back to start position. So if I wanted to like even go further, instead of saying move forward 70, I could say like move forward 140, and he'd end up like over here. And I could draw another letter and then have him go somewhere else and draw something else. If I wouldn't have said pen up, he would have just drawn a line that connected this. All right, 2.3.3 summary. We talked about methods. We talked about abstraction and how like you don't always need to know all the details. Abstraction is the removal of detail. Okay, the dot notation with the dot separator of an object and its method name. The method signature. The constructor. We've talked about constructors here for a while. We briefly touched on null point exceptions. I'm not going to press too far into that. A null pointer exception is, you know, as we get into exceptions more and more and errors that do come up, you may see a null pointer exception. It doesn't expect you to know the ins and outs of it. It's just saying, hey, look, this is what could occur. And we talked about object method, or a non-static method is one that is called, so one that must be called on an object of a class. Okay, so those are the methods that we've been calling from the turtle class. Okay, a static method is one that doesn't need to be called on an object of the class. So here's an AP practice, right? Assume the party object called my party has been properly declared initialized in a class other than party. Which of the following statements are valid? All right, so take a look at this. So we have a class called party. We have some instance variables up here. They're private. It says the num of people invited and whether or not the party's canceled, yes or no, a Boolean value. And this class can be reused for a bunch of different parties. You throw a St. Patrick's Day party, you throw a Memorial Day party, you throw a Independence Day party. You can pull from the party class. Okay. In this case, the default for a party, okay, you only invite one person and the party's not canceled. So it's just a party by yourself, I guess. Then it says public void invite friends, that every single time You invite a friend. We're going to add 1 to the number of people invited. Okay. In order to cancel the party, okay, if you call the cancel party method, so it'd be party dot or whatever you say, whatever you end up calling as your object, right? P dot cancel party, that will set party canceled to true. And maybe there's also some code behind the scenes that sends out a notification to everyone to the party and says, hey, the party's been canceled. Okay, which of the following statements are valid? Assume that a party object, has probably declared initialized another party. Which of the following statements are valid? Okay, so taking a look at this. Oh, my party. Okay, I see. All right, I was wondering where they got my party from. Like I said, not reading. Has been properly declared, initialized in a class other than party. Okay. So which of the following statements are valid? My party dot cancel party. Okay, that would set the party cancel to true. My party dot invite friend 2. The problem with that is it's not anticipating an argument being passed in. As you see, there's no parameter here. This is an argument. This is a parameter. There's no parameter. So B wouldn't work. Okay. N party, that there's no method declared in here called N party. Num invited, that's not a method. That's just a variable. My party dot num invited. Once again, N party, num, no, that doesn't work. And system.out.print, cancel party, my party dot cancel party. That would just print back true. Okay. So I'm not sure if it's wanting us to print out true. I'm not sure why it would. It's either gonna be A or E. Let's see if we got this right. A, yeah, because it doesn't really tell us why we'd be printing this out. Doesn't make sense. Okay, and plus it's a private, that it wouldn't run because it's a private variable, instance variable. Okay, 239. Consider the following class definition. We have a class called cat. It has a method called meow, and every single time it's called, it just prints out meow. It has a method called purr, and every single time it's called, it prints out purr. And then we have one called welcome home, and it purrs and meows. Which of the following code segments, if located in a method in a class other than cat, will cause message meow purr to be printed? Okay, first we need an object, okay, from the cat class. We have meow purr. This we have an object and it says welcome home, but welcome home prints out purr meow and not meow purr. Okay. In this case right here, what didn't actually work was, you see right here, it says cat.meow. It should say a.meow, a.purr. So C so far is right. That you can't do that with D there. You can't just add that plus welcome home would print out. Welcome home prints out purr meow and not meow purr. And then down here, that just meows. All right, so it's C. Let's go ahead and run it. That's right. Okay, so, if you briefly look at this, as I did originally as well, I'm looking at it, I'm like, oh, .meow.purr, but you have to actually use the object you created. You can't just use the class and say the class name. You created a specific object from it called A. So that's why this works. You created A. A is a new cat. You create another cat called B. You could another cat called C, and move on from there. Okay, it says you have attempted 9 of 9 activities on this page. Completed, well done. All right, so as we create objects, we can start to look through what's inside a class and find the methods and the properties and the attributes and the variables, and being able to change all of that as needed. All right. So that is 2.3, calling methods without parameters.